In this video, we're going to talk about comparing properties of linear functions. So sometimes you're going to have more than one linear function and each one is expressed in a different way. So if we look at this example here, it says the domain of each function is the set of all real numbers x such that x is greater than or equal to 5 and less than or equal to 8. So in other words, our domain, our x values, are all real numbers between 5 and 8. The table shows some order pairs for f of x, which is right here. The function g of x is defined by the rule g of x equals 3x plus 7. So we have two functions, f of x, which is shown to us as a table, and g of x, which is shown to us as an equation, as a function rule. So one thing that we can do to compare these two functions is by taking this function table for f of x and writing the linear equation, writing the function rule for this table. So what we're going to do is we're going to use point slope form, which means first we need to find the slope. So remember, the slope formula is y2 minus y1 over x2 minus x1. And I'm going to set this up with my parentheses. And then I'm going to label one of these points as x1, y1, and the other point as x2, y2. And now I'm going to plug these numbers in. So my y2 value is 24, and my y1 value is 20. My x2 value is 6, and my x1 value is 5. 24 minus 20 is 4, and 6 minus 5 is 1, and 4 over 1 equals 4. So my slope is 4. Now I'm going to plug that into my point slope form, which is y minus y1 equals the slope times x minus x1. And I'm going to set this up with parentheses, leave a gap for the slope, and then I'm going to plug in my information. My slope is 4. I'm going to use this first point here, so my y1 is 20 and my x1 is 5, and this equation becomes y minus 20 equals 4 times x minus 5. Now I want to continue because I want to write this in slope-intercept form, so I need to distribute. 4 times x is 4x, and 4 times negative 5 is negative 20. Bring down the rest of this, and then finally I just need to add 20 to both sides, and I get the equation y equals 4x plus 0, which I could just write as y equals 4x. And actually it's not y, it's f of x, because we're going to write this as a function rule. So the function rule for this table is f of x equals 4x. The next thing we could compare is the initial value. Now, the initial value is the output you get from the lowest possible input. And so since the domain for both of these functions is that x is greater than or equal to 5 and less than or equal to 8, which means x is all numbers between 5 and 8, the lowest input value is going to be 5. And we already know what the initial value is for f of x, because it says when x is 5, f of x is 20. So we can write here f of 5 equals 20. So now what are we going to do for g of x? We need to plug in 5 and solve. So we're going to say, okay, g of 5 equals 3 times 5 plus 7. Now 3 times 5 is 15, and 15 plus 7 is 22. So g of 5 equals 22, which means that the initial value for g of x is 22. So in comparing them, you could say g of x has a higher initial value or a greater initial value than f of x. Now we can also compare the domain and range for each function, but both of these functions have the same domain already. X is greater than or equal to 5 and less than or equal to 8. So let's just focus on the range. So we already have the range here for f of x. We see that the lowest range value is 20 and the highest range value is 32. So we can say that for the range, okay, f of x is all real numbers greater than or equal to 20 and less than or equal to 32. What about the range for g of x? Well, we don't have a table for g of x, but we already know the lowest output value for g of x. So now all we need is the highest output value, which is going to be where x is 8. So we can write here g of 8 equals 3 times 8 plus 7. Well, 3 times 8 is 24, and 24 plus 7 is 31. So where x is 8, g of x equals 31. So now we can give the range for g of x. And we could say g of x is greater than or equal to 22 and less than or equal to 31. So the range of f of x is all real numbers between 20 and 32, and the range of g of x is all real numbers between 22 and 31. All right, let's take a look at this next example here. The domain of each function is the set of all real numbers x such that x is greater than or equal to 6 and less than or equal to 10. The table shows some ordered pairs for f of x. The function g of x is defined by the rule g of x equals 5x plus 11. So let's go ahead and write the rule for the table f of x. So I'm going to set up my slope formula. y2 minus y1 over x2 minus x1. So we have here x1, y1, x2, y2. So 42 minus 36 over 7 minus 6. 42 minus 36 is 6. 7 minus 6 is 1. So our slope is 6. So now let's plug this information into our point slope form. So y minus y1 equals our slope times x minus x1. Our slope is 6. I'm going to take this first point. So our y1 is 36 and our x1 is 6. So this becomes y minus 36 equals 6 times x minus 6. And in order to put this into slope intercept, we need to now distribute. So 6 times x is 6x, and 6 times negative 6 is negative 36. Bring down the y minus 36. Then I need to add 36 to both sides to solve for y. And I get y equals 6x plus 0, which is the same as just saying y equals 6x. And again, it's not y, it's f of x. So we have here f of x equals 6x. So let's take a look at the initial value. We already know the initial value for f of x. It's 36. So we'll write here f of 6 equals 36. And now we need to calculate the initial value for g of x. So I'm going to write this over here. So I'm going to write g of 6 equals 5 times 6 plus 11. Well, 5 times 6 is 30, and 30 plus 11 is 41. So the initial value of g of x is 41. So g of x has a greater initial value than f of x. Now let's compare the domain and range. So the domain is the same for both of them. So the range, we already know for f of x, is going to be all real numbers such that f of x is greater than or equal to 36 and less than or equal to 60. We already know our initial value for g of x, so now we need to find the highest value for g of x. So we have to write here g of 10, because that's our highest input value, equals 5 times 10 plus 11. Well, 5 times 10 is 50, and 50 plus 11 is 61. So our range for g of x is all real numbers such that g of x is greater than or equal to 41 and less than or equal to 61. So let's take a look at this example here. It says write a rule for each function and then compare their domain, range, slope, and y-intercept. So it says a rainstorm in Austin lasted for 3.5 hours, during which time it rained a steady rate of 4.5 millimeters per hour. The function a of t represents the amount of rain that fell in t hours. The graph shows the amount of rain that fell during the same rainstorm in Dallas, d of t in millimeters, as a function of time, t in hours. So again, we have two different functions. One function is given to us in a verbal description, and the other function is given to us as a table. First, let's take a look at Austin. They tell us to use a of t because of Austin, right? So a of t equals what? Well, obviously, before it started raining, there was no rainfall, right? So our y-intercept is 0. So what is our rate of change? It is 4.5 millimeters per hour. So a of t equals 4.5 t. Now notice here the amount of time. How long did it rain in Austin? 3.5 hours. So we have to give here our domain. So we're going to say for t is greater than or equal to 0 and less than or equal to 3.5. That's the rule for a of t. So now let's go ahead and write the function rule for the amount of rain that took place in Dallas, which is represented by this table. So we see that our y-intercept is 0, so that's good. All we need now is the rate of change, or the slope. And this is kind of easy because our beginning point is 0, 0. So our change in y, we went up from 0 to 20. So our change in y is 20, and our change in x, we went from 0 to 4. So our change is 4. And 20 divided by 4 is 5. So our slope is 5, and our y-intercept is 0. So we could say d of t equals 5t. Now, for how long did this last? Well, look at the domain or the x inputs on the graph. Our last one was 4. So for Dallas, it rained for a little bit more than 3.5 hours. It rained for 4 hours. So we say 4t is greater than or equal to 0 and less than or equal to 4. So you can see that these two functions have different domains. So we know the domain for each function, we know the slope for each function, and we know the y-intercept. They both have a y-intercept of 0. So now let's go ahead and calculate the range for each function. Well, we already know the range for Dallas, so let's calculate the range for Austin. And Austin has this highest output of 3.5, so we need to work out for a of t equals 4.5t. So we have to say a of 3.5 equals 4.5 times 3.5, which is 15.75. So we know that the range for the function for Austin is A of t is greater than or equal to all real numbers such that A of t is greater than or equal to 0 and less than or equal to 15.75. And for D of t, we can see from the graph all real numbers such that D of t is greater than or equal to 0 and less than or equal to 20. Now we can go ahead and compare these. So we know that they have the same y-intercept. They both start at 0, and that just makes sense because before it stops raining, there's no rainfall. So they both begin at 0. We know about the domain. So Dallas has a different domain than Austin. Why? Because it rained longer in Dallas than it did in Austin. It rained for 4 hours in Dallas and only 3.5 hours in Austin. How about the slope or the rate of change? Well, Dallas has a greater slope than Austin. So what does that mean? That it rained at a higher rate than in Dallas than it did in Austin. And finally, our range. Our range in Austin was 0 to 1575, and our range in Dallas was 0 to 20. So since it rained longer in Dallas and at a faster rate, then Dallas had a higher output of rainfall. All right, one more example here. It says write a rule for each function and then compare their domains, ranges, slopes, and y-intercepts. So it says here, Jeff, an electrician, had a job that lasted 5.5 hours, during which time he earned $32 per hour and charged a $25 service fee. The function J of t represents the amount Jeff earns in t hours. Brendan also works as an electrician. The graph of B of t shows the amount in dollars that Brendan earns as a function of time, t, in hours. So let's go ahead and start with Jeff. So we see that he had a job that lasted for 5.5 hours, and he charged $32 per hour. That's our slope, that's our rate of change, and a service fee of $25. That's our y-intercept. So we can write the equation for Jeff, J of t. J of t equals 32t plus our y-intercept, 25. For, how long did it last? 5.5 hours. So for t is greater than or equal to 0, less than or equal to 5.5. Now let's go ahead and write the function rule for Brendan. So looking at the graph, we see the y-intercept is 40. So that tells us that Brendan's service fee was probably $40. And we see that the highest value here is 160 in 4 hours. So we have our y-intercept. Our y-intercept is 40. And now we need our slope. So we can actually get the slope very easily here from this graph. We see that the y value for this point is 40. And the y value for this point is 160. So the difference from 40 to 160 is 120. So we have a change of 120 for y. And then if we look at x, we start at 0 and end at 4. So the difference is 4. And 120 divided by 4 is 30. So that's our slope. So now we can write our function rule for Brendan. So B of t equals, he's charging $30 an hour plus a service fee of $40. And he worked for 4 hours, so that would be for t is greater than or equal to 0 and less than or equal to 4. So we've written the function rule, we know the domain, we know the slope, and we know the y-intercepts. All that's left is to identify the ranges. We can easily identify the range for Brendan from the graph, so let's go ahead and find the range for Jeff first. We know his low value is going to be $25 because that's his y-intercept. But what's his high value? So we need to figure out how much did he make in 5.5 hours. So we're going to substitute. We're going to say J of 5.5 equals 32 times 5.5 plus 25. (32 times 5.5 is 176, and 176 plus 25 is 201. So now we know Jeff's high output value, and we know his low output value is going to be his y-intercept, which is 25. So we can write the range for J of t is going to be all real numbers such that J of t is greater than or equal to 25 and less than or equal to 201. And we can get Brendan's range by simply looking at the graph. We see his low output is 40 and his high output is 160. So we have all real numbers such that B of t is greater than or equal to 40 and less than or equal to 160. And again, the reason why Jeff's low output value is 25 is because he is charging that service fee before he even starts working. And the same thing for Brendan. He's charging a service fee of $40 before he even starts working. That's why that is his low output value. So let's finally compare everything. With their domains, both start at 0, but J of t ends at 5.5 and B of t ends at 4. Their ranges are, as we discussed, J of t is all real numbers between 25 and 201, and B of t is all real numbers between 40 and 160. Their slopes, Jeff has a higher slope, or Jeff's function has a higher slope than Brendan's, which means what? Jeff has a higher rate of change. Jeff charges more per hour. He charges $32 per hour. And their y-intercepts, Brendan has a higher y-intercept than Jeff, and that's because Brendan charges a higher service fee than Jeff. All right, I hope this video helped you to understand how to compare the properties of linear functions.